Hey guys, it's Drew. Just thought I'd drop in tonight with a quick sneak peek of the sensors I'm going to be using in the HASSP project. So what I have here is I have a very small Arduino. Now this looks way different than many Arduinos that you may have seen or worked with before. It's because it's still wired to the Arduino spec, it's just really small. It doesn't have a lot of the things that your normal Arduino does, and it kind of forsakes the pins that you would plug wires into for pin through soldering, which is what this has. It's also connected to a USB header here. This is what we use to power and program the device, so when I upload the sketches that will be recording the data, this is what it's used. You can also power the device through this. Not sure if I'm going to leave that on for the flight or not. I could also wire in directly. Underneath there are a bunch of pins. I could wire up power directly to it if I wanted to as well. So on the Arduino, and you can just kind of get an idea for how small it is because I have really small hands to begin with, you can see that I have about 5 wires soldered into it. So you got a red wire here on an analog pin, and then on the underneath here you can see that I have a white wire for my voltage in and a black wire for my ground. Then coming through the top of the device here to pins 4 and 5 on the Arduino, soldered into the back here, probably the best solder you're going to see this whole video, spoiler alert, is the SDA and LCL pins of the port as well. So this entire project uses using I2C wiring, just for sake of kind of not having a ton of wires going anywhere, because as we kind of come down here, you'll notice that I have kind of a rat's nest of a breadboard with pin through soldering. So the nice thing about I2C wiring is it lets you basically reuse those ports. You don't need different pins for all the different sensors we're going to wire up. So this kind of breadboard here kind of acts as like a central terminal for all the different connections. So on the back you can also see some really bad soldering. I don't know what it was about this. I've never really done a lot of pin through soldering on a breadboard before, so this was kind of a new exercise for me. You can see here I experimented with a couple different ways to do this, but in the end I just gooped it all on. Seems to work just fine. So there's all those connections being made, and then this breadboard just basically acts like any other breadboard where all these wires kind of feed off each other. So we have the blue wires there, which is my SCL port, and then the yellow wires are the SDA, and then of course white being voltage and black being ground. So real quick, let's walk through some of the different sensors here. So if we follow this red wire down, we can see that that is just hooked up to a plain old temperature sensor, and this temperature sensor is going to be on the inside of the balloon payload. This will be monitoring the temperature inside in case we want to see what goes on as this thing travels on the inside. So that's what's wired up to that analog pin all by its lonesome with the red wire, and then we have voltage and ground going to that. This will just output, when we pull it, any type of Fahrenheit, Celsius temperature, whatever we want. Then we also have this guy, and this one's a little more complex wiring. So again, we have ground and we have voltage, the GND and VCCR. Then we have that blue wire for the SDA and the yellow for the SCL. This is an accelerometer, and this will also be on the inside of the balloon payload, and it is going to give us X, Y, and Z measurements on what's going on from the gravity perspective as this thing flies. So this should give us a profile of, as it flies, what are the forces being exerted on it. I would expect to see, as it's going up, gravity interacting with it as it flies up, and then as it pops or bursts at a certain altitude, we'll see it kind of free fall. We'll be recording all of that with this accelerometer. This will give us X, Y, and Z gravity ratings. And the final sensor, which is on a very long spool of wire, I'll explain why in a minute. Again, 4 wires here, and I had to switch to green instead of yellow because I ran out of yellow wire. So this is our last sensor, and the reason that this is a little bit longer is because this is going to be a sensor that goes on the outside of the balloon payload. This is also a temperature sensor, but it also does atmospheric pressure, and that's going to be important because if you know atmospheric pressure, you can also calculate altitude. So this sensor is going to be on the outside of the payload, and it'll be logging all the same temperature data that the other sensor does, but it's going to give us the outside reading. And it's also going to tell us what the atmospheric pressure is outside, so we'll get a rough idea of what altitude these readings are occurring at. So that's pretty cool. Interesting thing about this is we threw this sensor on top of some blocks of dry ice, and it performed perfectly, actually, no problems at all. I think the sensor itself is rated to -40 or -50 degrees Celsius. I think we can probably expect temperatures that cold up there in the upper atmosphere, but we're not really sure. I guess we're going to find out. So this will be on the outside of the balloon, kind of balloon payload, recording that data and writing it back as well. So that's just a sneak peek of the wiring that we're using. These are the various sensors, and in future videos I'll be outlining the rest of the hardware, how it all interconnects, and the software. So thanks a lot, guys. Thanks for watching.